Hey guys, in this video I'm going to show you how to solve the 2015 free response problem number 3. So let's talk about it for a minute. I'm sure everybody had a chance to read it, but we'll just really quickly read it again. A shopping mall has 3 automated teller machines or ATMs. Because the machines receive heavy use, they sometimes stop working and they need to be repaired. We're going to let the random variable x represent the number of ATMs that are working when the mall opens. So once again, if you've seen my past videos, this is what we call a probability distribution table. One of the most important things to do is take a look at what this variable represents. Because typically in this problem, they'll ask you to find the expected value, and you want to know what you're finding the expected value of. So in here they say X represents the number of ATMs that are working when the mall opens on a randomly selected day. The table shows the probability distribution. So one thing also is that these must add up to one whole, and that's very important. So that just means that there's no more than 3 ATMs in the entire mall. So it says, what is the probability that at least one ATM is working when the mall opens? What is the probability at least one? Typically, we think of NCR when we think of at least one, but this is just a basic general question. It's not saying, hey, if we took 3 ATM machines, what's the probability at least one will work? It's just asking you, what is the probability at least one will work? So that's the difference. That's why we're not using the NCR method. So in this case, probability at least one is basically 1 minus the probability of 0 working. And so 1 minus 0.15 is 0.85. And that's part A. In part B, they said, what is the expected value of the number of ATMs? So if you remember from my past video, you'll remember that all you have to do to find the expected value is take each X and times it by the probability of it happening. So we got 0 times 0.15 from here. And then we have plus 1 times 0.21 plus, that's from this guy, 2 times 0.40 plus 3 times 0.24. And that value is just going to be about 1.73 machines. Don't round this up or down, just leave it as 1.73 machines. So that's the expected value of, that's the expected value of the number of ATMs that are working when the mall opens. Now this part is a given. It says, what is the probability? So I'm just going to get rid of some of this stuff here. It says, what is the probability that all 3 ATMs are working? That all 3 ATMs are working when the mall opens, given that at least one ATM is working. The reason why this given is different than our other given type problems is because this is in a single row. This is just in a single row as opposed to a table. So there's no overlapping. So if you just thought about it in plain English, what you would think is saying given means out of. So at least one of the ATMs is working. Well, we found that in part A. So that's going to be 0.85. Given that at least one ATM is working, okay, so that means this right here. What's the probability that all 3 of them are working? So that's 0.24. Yes, the notations are still the same. The probability that x equals 3, given that x is greater than or equal to 1. But in this case, when we take a look at this part here, there really is no you're basically using one set and then you want a subset of that set. It's not a table. That's why we're not doing any intersections here. So it has to be equal to 3 and must be at least 1. So this is the only guy that's equal to 3 and at least 1. So that's the numerator divided by at least 1, which we found in part A. And so our answer is going to be, remember never to put two decimals as a value. It's going to be 282. So I hope that makes sense. So out of the, given at least one ATM is working means out of. So given at least one ATM is working. So out of those three, what's the probability exactly 3 ATMs are working? So that's how you do part C. And part D is, so you're going to have to remember that this probability distribution must add up to 1 in order for us to work. Now, it says, given that at least one ATM is working when the mall opens, would you expect the value of the number of ATMs that are working to be less than, equal to, or greater than the expected value from part B? Well, many people probably said that it's going to be exactly the same because this guy has no effect on the answer. So if we just got rid of him, it doesn't matter because 0 times 0.15 is 0. And so it's not going to affect the answer of the expected. But remember, you are not allowed to use this formula. You are not allowed to use this formula where we multiply and add unless we have these values equal to 1 whole. So this 0.15 has to get distributed to either him, him, him. It could be some to him, some to him, some of it to him. It could all be to this one person. It could all be to this one person. But one thing that you notice, regardless who you give this 0.15 to, whether it's him, him, or him, you got to give it to somebody. And that, when you multiply it by either 1, 2, or 3, is going to increase the expected value. So the expected value of the number of working ATMs would be greater than 1.73 because the 0.15 would get distributed to one of the other three X's. So I hope that makes sense. I hope this was a good problem. I hope it was an easy problem.